All right, so let's do the lesson 5, or unit 5, lesson 7 practice problems. Starting with the warm-up, we're only asked to indicate whether these questions result in a positive, negative number, or 0. And this is just basic practice of the rules that we've been learning. A positive number times a positive number gives you a positive. So we'll just leave a plus mark in there. For the second row, a negative times a positive is a negative. In the third row, negative times negative is positive. And for that last row, we learned a trick for when we have more than 2 factors. If you count the number of negative factors and the number of negative factors is odd, then your product will result as a negative. Had it been a even number of negative factors, then we would have resulted in a positive product. All right, problem 1 is essentially the exact same thing, but this time we're being asked to actually determine the value of the expression, or in other words, get the answer. 5 times negative 3, the same as 5 times 3, which is 15, except it's negative 15. Negative 5 times 3 has the exact same product as 5 times negative 3. Multiplication is what we call commutative. Doesn't matter which order we multiply, we still get the same answer. Negative 5 times negative 3 is also 15. This time the answer is positive, as a negative times a negative is positive. And then in the last row, I see that it's negative times negative, so I know my answer is positive this time. And it's also still 5 times 3, except that 3 has been moved over 1 decimal place. So my answer will be moved over 1 decimal place. Instead of 15, it'll be 1.5. All right, problem 2.1 says a bug is crawling down a tree at a rate of negative 7 millimeters per second. I think we're supposed to interpret the negative in this rate as the downward travel. So it's kind of weird because when I first read this, I thought down at negative rate should really be up. But I think the way they mean for us to interpret it is that the negativity is the downwardness. So which equation represents the bug's position 8 seconds after it passes the branch being 0, like on a number line? So remember, these are the practice problems that go with that turtle lesson that we did recently in Desmos, where when the turtles were traveling left on the number line, they were going into the negatives, and that was like negative rate of travel. And as they went right, that was positive rate of travel. It's the same thing. The tree, going down the tree is negative, going up the tree is positive. So let's see here. We have negative 7 times 8 equals 56. Well, that can't be right off the bat because negative 7 times 8 is negative 56. Okay, so this one says negative 7 times 8 is negative 56. That one sounds like it's probably right. And the last two, both the rate and the time are negative, but I don't think we should have negative time in this one. It doesn't say anything about like 8 seconds ago, like it would say in that turtle activity. So I think this answer here with negative 7 for the downward rate times 8 seconds for 8 seconds in the future would get us negative 56, or down 56 on the tree. All right, so the next question says, same thing, still a negative rate of 7 millimeters per second. But this time they want to know where was the bug at 8 seconds before passing the branch. And so this is 8 seconds back in the past, or negative 8 seconds as the activity likes to refer to it. And so we should be looking for negative 7 times negative 8. We have 2 options to say that, but we want to pick the one with the correct product, right? And that's going to be the one with positive 56, because 8 seconds ago, the bug was higher up in the tree. So that's why that's where the positive 56 comes up in this answer. So describe a situation that can be represented by the equation 7 times negative 8 equals negative 56. For creating questions that have to do with negative numbers, I think temperature is one of the easiest ways to do that. And when I see the number 7, it makes me think of days of the week. And so I would write something along the lines of the temperature dropped every day. I guess I should have said temperature dropped by 8 degrees every day for a week. What was the total temperature change? And so you would do the 7 days of the week times -8, representing the fact that the temperature was changing in a downward direction each time. And so you would have a total temperature change of -56 degrees at the end of that. All right, so it says the bug has friends on nearby trees. For each description, write equations similar to problem 2, the one where the bug was going down at -7 millimeters per second. So assume each bug starts at the same position as the bug in problem 2. Where did the bug in problem 2 start? I have to go back and look at that. I guess the starting position is always the branch that is position 0, I think. So the first description says Buggo crawls for 28 minutes at a rate of -2 centimeters per minute. Okay, so the rate is -2, and we're going to multiply that by, I wonder if I can get the dot. Yep, we're going to multiply that by the time, which is 28 minutes. And now it says that we have to have an equation. So equations have equal signs, and they have values or expressions or variables on both sides of the equal sign. If you leave it just like this, -2 times 28, that's an expression, not an equation. So in other words, we need the answer, which in this case would be -56. If you don't know how to get this dot on your screen, or you don't have it, I believe you can also use an asterisk to mean, oh yeah, I just typed an asterisk and it gave me that dot instead. So that's just as good. Asterisk is above the H key on your keyboard. Or you can also put things in parentheses, do it like this. All right, so the next one says buggy slides for 3.2 seconds at -8.1 millimeters per second. So I'm going to do the negative rate, -8.1 times, so I'm doing shift 8 to get this dot, 3.2. That's going to equal, you know, I think if you type it into this keyboard actually, or this calculator, it would have given me the answer. I'm actually surprised it's not giving me the answer already. What happens if I hit this? No. So if you ever need help getting the answers in Desmos, so you can always open this keyboard thing, and as you press it in, it should, can I get equals? No. Okay, if I do it like this. Well, anyways, let's hear 8.1 times 3.2, 24.3, 6, 24.455, something like that. I don't know. Let me try retyping it in here, see if it gives me the answer. So -8.1 times 3.2 equals. No, it's not going to give it to me. All right, well, I'll just use an actual calculator. Looks like it's 25, negative, I should say, -25.92. All right, and the last one, bug creeps for 3.5 seconds and finishes at -28.5. So this one's a little different than the rest of them because they've only given us the time and the final position. And in this case, it's our job to find the rate. So we could find that rate by doing -28.5, the final position, divided by 3.5 to get the rate. looks like it's going to be crazy decimal, 8.14 something something. So the equation is going to be 3.5 times negative 8 point, I'm just going to round it to 8.143 equals 28.5. All right, so a tank of water breaks and begins draining at a constant rate. Complete the table. So a constant rate tells us that there's going to be a constant of proportionality. This is a proportional relationship here. And so if after 1 hour, the change is negative 14 or it's lost 14 gallons of water, then that tells me every hour it's going to lose 14, right? That's its unit rate. So 2 times negative 14 is negative 28. And 5 times negative 14 is negative 70. And so it looks like the tank began with 770 liters in it. That's what this number here at the beginning represents. And then we're adding the change, but the change is negative. So that's going to cause the water in the tank to go down. And so the next number in the expression should always be the number of hours that have passed. And then that last number will be the rate, which is the negative 14. And so the answer to this expression would be how much water is left in the tank. But really, you're just doing the original 770 minus how many gallons have leaked out or plus the negative change there. And so this is going to be 770 plus negative 28. That's 42. Is that right? Yeah, 742. And then this one will be 770 minus 70 or plus negative 70, which is 700. And the expression will be the original 770 gallons in the tank plus the 5 hours that have passed times the rate of change, which is negative 14. Okay, so is there a proportional relationship between time and the amount of water left in the tank? So not the amount of time and the change. There is a proportional relationship there. It wants to know about a proportional relationship between time and the water left in the tank, the fourth column there. And I can very easily see that there's not, because in order to have a proportional relationship, you need to have 0, 0, or you need to have 0 for one value and 0 for the other. And at 0 minutes, I've got 770 gallons in the tank. That right there is enough for me to know that it's not a proportional relationship. All right, and so for the Explore here, it says each number is the product of the two numbers directly below it. So for example, this -2 right here is the product of 2 and -1. And so we can complete the pyramid. If I look at this box here, it should be the product of -1 and -1. That's 1. And -2 times 1 is -2. Now to fill in these boxes, you kind of have to work backwards using division. -1 divided by 1 is -1. You can figure out what 2 divided by -1 is. That would go here. And so basically you work your way up with multiplication, work your way down with division. I'll leave the rest for you to fill in. And this one is the exact same thing, just the numbers are a little bit bigger and more challenging. You don't necessarily have to complete the 2 explores, but I need to see that you at least tried them. All right, that's it.